Hi, my name is Laura Byrne and this is my presentation on lasers for the Tyndall and IPIC Student Summer Internship. So first of all, what are lasers? Well, the word laser is an acronym that stands for Light Amplification by Stimulated Emission of Radiation. This means that a laser is created when the electrons of an atom within a controlled medium absorb more energy, causing a photon to be emitted. Laser light travels in waves, and the distance from one peak to the next of that wave is referred to as one full wavelength. The wavelength of a laser determines what color of light it will be. For example, blue light has a much shorter wavelength than red light, as you can see here. Light from lasers differs from regular white light in three ways: coherence, monochromaticity, and directionality. Coherence means that the peaks of each wave of laser light are all aligned so that they travel in parallel lines. Monochromaticity means the light has one specific wavelength and that each wave in a laser will be the exact same color. Laser light is also highly directional. Due to the synchronicity of the waves in a laser, it produces a very narrow beam of light which is both strong and concentrated. So how do they work? In order to create a laser, we need a medium, which can be seen here. We also need the medium to have atoms with electrons that we can stimulate. The medium can also be referred to as the amplifier. We need something to stimulate these atoms like a very powerful lamp. So once you add energy to the atom inside the medium, its electrons become excited and jump to a higher energy level. Unstable at this new energy level, the electrons fall back down to their original state and emit energy in the form of light. There are different types of lasers split into categories based on the medium used to create them. These are gas, solid state, liquid, and semiconductor. Gas lasers discharge an electric current through a gas-filled medium to produce laser light, such as the helium neon laser. Solid-state lasers use a solid as its medium, such as glass or crystalline, and this creates the ND-YAG laser. Liquid lasers use liquid mediums, and this creates the dye laser. And semiconductor lasers use a semiconductor medium, like a diode, and this can create the GaN laser. Lasers are also split into groups based on how dangerous they are, and these are called its classes. In Class 1, lasers are considered to not be harmful unless disassembled. This class includes lasers such as the ones inside a CD or DVD player. Class 2 lasers are lasers which shouldn't be viewed or make contact with the eye, such as a barcode scanner seen in many shops. Class 3 lasers are split into two subgroups, Class 3OR and Class 3B. Class 3OR lasers are lasers which are considered a hazard if they are collected and focused in the eye. Most laser pointers are considered to be Class 3OR. Class 3B are lasers which are harmful via a direct or reflected beam into the eye. Ultraviolet and infrared lasers are examples of this. And Class 4 lasers are the most dangerous of all the groups and can cause serious eye and skin injury from both direct and reflected exposure. Caution should be taken when using these lasers as they are also a fire hazard. Most lasers in the Class 4 category are used by trained professionals in areas such as scientific research or surgery. Lasers are also a common constituent in everyday life. The most familiar uses can be seen here and include hair removal, eye surgery, Christmas decorations, tattoo removal, microscopic applications, barcode scanning, and dental surgery. There are a few methods in which the properties and applications of lasers can be understood at home. The first method is to create a laser maze as such. When you shine a laser at an angled mirror, the laser will bounce off the mirror at the same angle that it hit it. This demonstrates the uniformity and coherence of the laser beam. With multiple mirrors set up around the maze as seen here, the full light intensity from the laser will reach the detector, whereas white light often bounces in multiple directions once it hits a reflectant surface. This means that the white light won't reach the detector. Another source for understanding lasers is the online laser simulation offered by the University of Colorado in Boulder. Its official website is linked here. This image shows the simulation in which you can alter varying factors. You can increase the intensity of the light source that provides energy to the medium. You can change the wavelength of the light to its different colors. And you can alter the energy of the atom inside the medium, deciding if it needs a lot or a little energy to produce light. This application is really beneficial for understanding what components are vital in the production of laser light. Thank you for listening to my presentation.